I am strongly encouraging women to participate at PasswordsCon to get into information security. I have been co-supervising a master student that did a talk here last year, and she also spoke at DEF CON with a room completely full. Did a great talk, and I really, really appreciate to see more women getting into this stuff. So if any women have anything to talk about related to passwords in any way, let me know, okay? Very easy. Okay, so this is Nick Sullivan. He's head of cryptography at Cloudflare, and last year at McCarran Airport, I was seriously friggin' tired of Las Vegas. I was going home, and I was just walking there like a zombie, and suddenly there's this bearded guy coming up to me like, hey, you're Per Thorsen, right, running the password sec? Yeah, that's me, I want to go home. And it was Nick. And he said, yeah, dude, I'm kind of working on something, and I might have something for you at a later point in time. And look, here he is. So Nick Sullivan, and PAL is your PAL. Go ahead.
All right, thank you. Thank you, everybody. Yes. Raucous audience. Thanks for coming. It's 5 p.m. for this talk. And also, everyone online, thanks for watching. So I'm going to talk to you guys about a tool that we built at Cloudflare to help manage secrets, and specifically secrets relating to orchestrated, containerized environments. And that sounds a little complex, but I'll get into it. It's very simple. So we have a problem. A very basic problem, which is we have a container that's running in a server that needs an API key, and our Docker container is built from source, and we don't want the API to be in source, the API key to be in source control. And the solution we came up with was, excuse me, basically encrypt the secret before putting in the container, and run a trusted agent on the host that's underneath the layer where the Docker container runs, that has access to the decryption key for the secret. And when you run your Docker container, have a special entry point that talks to the host to get the secrets decrypted before it runs. And that's the essence of what PAL is. So if you need something that does that, this is your tool. So we're at PasswordsCon, right? So what does this have to do with passwords? Well, it doesn't directly have to do with passwords, but it sort of has to do with the broader concept of secrets and secret management. And typically, secrets used for authentication come in three major flavors. There are sort of sub-flavors and subtypes, but you have passwords, you have bearer tokens, which are strings or objects that represent an authentication, and you have private keys or secret keys. Now, passwords, as you probably heard 100 times over the last 2 days, these are stored by human memory. These are things that people are supposed to remember and manually enter into computers. And if you're sending them from a client to a server, it should be over an encrypted transport, or someone can copy it and replay it. By contrast, bearer tokens are high entropy strings. They're things that a human being is not going to remember. It's something that you store in your computer's memory. And typically you can get them in exchange for a human-oriented password authentication. And there's examples of this abound, right? Cookies are an example, API keys are an example, and these again need an encrypted transport. There's also an expectation of these that they have a certain lifetime, which may not be the case with passwords. The third type of authentication we can think of as private keys. So when these are kept on your client, and they're oftentimes passphrase protected. So they are encrypted on disk and unlocked with a human memorable phrase that's a lot like a password. And when unlocked, you keep them in this sort of persistent memory on the system, and they allow you to do some really nice things, such as digitally sign requests, so that your authentication doesn't have to necessarily go over an encrypted transport. But this complicated nature of it's a key, sort of a random long string, makes it very difficult to be portable. Another example of this would be is two-factor authentication. So the codes that you generate from two-factor authentication, these are derived from a key that belongs to a secret key that belongs to the client. So passwords, as sort of human memorable things, they have these requirements of being strong, sort of unpredictable, and different per site. This is oftentimes very hard for human beings to handle because now this is from Dashlane's blog. People have on the order of 100 or so different logins. So remembering a different password for each one of these is a serious mental challenge. So for remembering passwords and for dealing with authentication, we've derived some of these tools that sort of enhance our capabilities to make us kind of superhuman password remembering folks, and password managers are one example. So they support things like syncing across devices, having a passphrase that kind of turns your password into the same security style as a private key would. So you have a passphrase to unlock it. And you can configure permissions as to which applications have access to these passwords at one time. And they have another feature called strong password generation, which some people use, some don't, but it allows you to turn a password into essentially what a bearer token is, like a long entropy-ridden string that makes it a lot harder to crack. But then it also makes it so that it's not something that is human memorable. You still have to remember the passphrase to unlock the passwords. But this is one example of a tool people use. And when you're in an enterprise or an organization, there's oftentimes shared passwords. And these are sometimes passed around with sticky notes or email the administrator and these sort of things. Very, very bad practices. But another tool was built for this, and this is the set of enterprise password managers. And this is kind of like a centralized police officer with a case right there that has a list of policies that says who is allowed to have access to these passwords. And in this example, someone wants access to the Visa account, and they bootstrap this based on regular authentication. So the user says, hey, I'm this person, here's my credentials, and the server will say, okay, well, here's a temporary use for this sort of shared password. So password managers and enterprise password managers are really human-centric. They're built with people in mind. They're built so that you have manual interaction. They're built so that individuals can manage secrets. And these tools are very useful and very helpful. So, but this is not what my talk is about. My talk is about the other side of the story, not clients as sort of computers or phones or something like this, or individuals, but it's more as servers. So servers need secrets too. And the way that people manage secrets, passwords, and these sort of credentials for servers are very different than the human-centric password-based mechanisms, because computers are not people, right? So servers need secrets. And just as an example, if you're building a web service or you have some sort of server up in the cloud that does some things for customers or for people, you may need API keys. You might want to talk to other servers doing so. You might need credentials to access dedicated databases, or you might want to be the terminating layer for HTTPS or TLS and keep the private keys. So these are things I don't recommend, but what some people do in this case is they have, well, the very first thing that you can do is if you manually manage your server, you can just log in and write the secret into the server. But if you're working at any sort of scale, this sort of manual work is automated by a configuration management system. And what people can do is put the secrets into the configuration management system. These are things like Ansible or Salt or Chef or these tools that make it simple to configure your servers. And then they take the secrets and they put them on disk or in environment variables, and then they just trust whatever applications are on the machine to access the right variables using system-level controls. So when you're talking about environment variables, you can define an environment variable ahead of running a command in Unix, and other services can find out what that is by looking to see what the command was to operate these these functions. So you're really trusting a lot of system processes to keep these secrets isolated from one service to another. As I mentioned, system ACLs. So you can have services running under different accounts, and this is really, hard to manage and easy to break. Privilege escalation is one of these bugs that we see all the time, and relying on this is potentially not the safest thing to do. If you're working with a bunch of developers, you may have a development environment and a production environment. And if you just keep your secrets in configuration management, then all your developers have access to it as well if they want to build a coherent development environment and be able to test these things. And that means that your configuration management is in a source control that's accessible by non-operators. And that extends your trust to everybody at your company who's potentially a developer. And this is not really this is the way that some startups do it, but this is not really a safe long-term approach. And furthermore, applications are developed by different teams. So if someone on some team runs an application on your server that is maliciously or not trying to access secrets that are only used for other services, you don't really have this strong boundary level here. Now, this is obviously sort of a straw man, but people do implement their servers and protect them in these ways. So what are some potential solutions for this? Well, more commonly, people do this thing where they encrypt the secrets in source control. And then they take their set of secrets, they make a parallel set for development to talk to development servers, and a set for production that's encrypted that can only talk to other production servers. And the secrets in the configuration management, they are encrypted with a key that's only held by one secure box. And this is sort of one node that is deploying the configuration outwards. And you reduce your trust space from source control management, which is accessible to everybody, to some one dedicated machine that you can lock down the access to. And when you add new machines into your system, they have to authenticate with this configuration management master node, and it will be able to distribute the secrets. So this is not something new. There are secret management tools, and this is something that has abounded over the last couple years in terms of open source solutions. So you may have heard of Vault or Knox from Pinterest or KeyWiz from Square. There's a bunch of other ones. Lyft built their own. But they all have sort of the similar architecture. And that is essentially you trust your machines on first use. So whenever you provision your machine, you give it an identity. And then this identity is what's used to, you sort of manually accept these machines as part of your system and trust it on the first time you see it. So you create a machine identity at provisioning time, and then you can create this identity key pair and register it. And this is a very common pattern. And as I mentioned, Vault, KeyWiz, Knox, these sort of take this to the next level. But the basic idea is trust on first use. And this identity that's provisioned to the machines is used to bootstrap a secret management tool. And so I mentioned a few configuration management tools before. They have these plugins that do this. So Salt has a GPG plugin where you give a GPG master key to the Salt master. Chef has something called encrypted debags, which is just really funny to say. And Vault, KeyWiz, and Knox are a little more complex, but they have really sort of interesting password rotation and account rotation features built in. So once you log into Vault, it can deliver all the secrets to you. KeyWiz has this nice thing where it mounts a fused file system, like that looks like a file system that holds the secrets, and whenever you access them, it does a secure tunnel back to a central secret management server. But as I mentioned, the downsides here are that you have to have a secure secret server already running. So this kind of makes a two-class system, really, where you have some small trusted machines, and then this lets you bootstrap and send secrets to all the rest of them. So for people who don't do a lot of server development, you can think of this, here's an analogy for this, which is kind of a permission system like iOS or Android has. And you can think of your machine as an application, your permission settings as this configuration management system. So if you approve and disapprove different accounts to, different applications to do different things, this is like configuration management. And your secrets would be system resources. So if you get a new application, it can try to access these secrets if it is in the proper configuration management system. And that's sort of one way of thinking about it. And this is great, but we're in 2016, so a lot of these things don't often apply. So it's great if you have a single team, if you have a shared configuration management system for your entire company, or your number of servers scales to the point where you can manually approve them all. This is the third one's typically the case, but this is not how modern server deployments are going in the future. We've got this. There's this trend: Docker everywhere. You've heard about this a lot. Docker is not the only technology in this space, but generally, containerized deployments are becoming very popular. So in the last 10 years or so, it was more typically you have a virtual machine that has a full machine image, and in Docker, it's sort of a more compressed version of that. And if you look at this diagram, it sort of explains how in the old case, which is you have an entire guest OS, and this sits on a hypervisor, and you can have entire systems going 1, 2, 3, and you can use trust on first use to bootstrap the secrets for those. But in Docker, it's a little more compressed. You have not an entire operating system, but you just have a small amount of just the code you need and sort of a shared substrate of the system. And this changes things quite a bit if you consider your data center, because there have been a lot of tools built on top of it to make an entire data center and a lot of machines look more like one computer than like individual servers. So Mesos and Kubernetes, Docker Swarm, these are these orchestration frameworks that really make it so that when you deploy services onto your servers, you don't know how many servers there are, and you don't really care. You're just treating the entire set of servers as an operating system, and you use Mesos or something like this to distribute resources for it, just like an operating system would. So if you compare your applications inside a virtual machine to your applications inside of a Docker container, there are some very stark, important differences. And in the Docker world, your applications are ephemeral. They can go away. They're designed to be able to shut down and spin up all the time. So, for example, in Marathon, which is in Mesos, it's sort of the equivalent of systemd. They have another thing called Kronos, which is the equivalent of cron. But for Marathon, there's a button in the UI that says scale. And you say scale, and then you say how many versions of these do you want, and then it just goes out there and deploys them all. This is not something that's really going to work well with trust on first use. You're not going to scale 90 or 2,000 copies of an application and then sort of approve them all, because they could be deployed anywhere in your infrastructure. So in the Docker world, you have one application per container. In a VM, you have this sort of world of applications inside each container. And the other important difference is this Docker world lets you have different teams deploy things independently. You don't have to go through a centralized configuration management system. You can say, this is a shared operating system space or a shared server. You can deploy stuff here, you can deploy stuff there. Different teams can manage these independently. So you may have read this. This is just last week. Vine had this Docker registry issue. I can sort of walk this if you guys haven't read the news, but basically docker.vine.com, which was their Docker registry that had all their Docker containers, was publicly routable. And somebody found it and was able to download their live production copies of their backend And they were using, I believe it was Python, so they could just read the entire code. So they had the entire code base of all of Vine's backend. And more than that, they had API keys, they had secrets embedded inside the containers, and these were just all fully revealed from just the fact that their Docker registry was open to the internet and not requiring authentication. So this is the worst case for deploying secrets in Docker. And there are a couple lessons we can learn from this. And these are just basic, very basic things. Is use access control for your Docker registry. Don't register containers that have secrets inside. And sensitive code in containers is dangerous. This third one is kind of hard to get around in a lot of cases. But the first two are really kind of obvious lessons that you learn. So if you think about it, we can go into the sensitive code. I have an example on that later. But when you have Docker containers, the application model for Tofu doesn't really work. You don't have, I understand these are, I've deployed my 60 servers and I know where they are and I know how they're configured. You have applications in the thousands. So Docker containers, how to secret. How do we do it? So an interesting way to think about this is to take another permission system analogy. And if you think of how iOS or Android constructs things, they have these sandboxed applications. And they all kind of live in harmony on the machine and talk to the host to get access to system resources. So this actually maps up pretty nicely with the data center operating system model, where every container is like a signed application. And if you have a container and you want to release it, you code sign it, and you do code signatures, and you do that at the mastering release time. And your applications are sandboxed, your containers are basically sandboxed. It's basically sandboxed. And if your application wants access to secrets, it talks to the host. And the host can sort of check these entitlements and deny by default, just like your application can ask for access to your camera, and it would be denied by default. You'd have to sort of manually approve. This has practical differences between sort of an iOS kind of single application holding phone to an entire data center, because it's fully multi-tenant. You have multiple teams developing different things in parallel. So sometimes your secrets are unique per app too. It's not like every application wants access to the camera secret. You can have application-specific secrets. So this leaves us in kind of an interesting question and in place is what's missing? What's the missing link to make this model work? And that's really container identity. And this is your whale passport. This is what Docker containers use to prove who they are. But essentially, you have containers and they have to have identities that you assert. And luckily, Docker has built this tool for this called Docker Notary, which is just like a code signing tool. So a Docker container is built in a bunch of layers. This is a digital signature over those layers. And you can build a PKI on that, and you can sign it at mastering time. You can do key delegation, all these sort of nice things around that. So given that you have identity for your Docker application, let's put this into a visual. I've been talking a lot in bullet points and sort of generalities, but let's look at it. So we have a host. We have a container running on the host, and say you have a secret manager. This is just something running on the host that has access to a database of all these secrets. The container will say hello. The secret manager will ask Docker Notary, is this a real legitimate signed container? And does it have access, basically, is this a legitimate container? And if so, it will give the container its identity secret. And an identity secret is like a key that says this, sort of very similar to how we described earlier with the host. When you securely provision a host, you give it an identity secret, which is a key that says, yes, this is really who I am. This is this machine. It's been provisioned. And then that is used to bootstrap secret managements. In this case, each container gets an identity secret that's tied to what the application is. Now, this is a little bit heavyweight because this secrets database, deploying this to every single one of your hosts is kind of dangerous. I mean, you want to limit access to this. This is potentially, how do you protect this? This is something that has all your secrets. So another way to organize things is to, rather than having your entire secret database live everywhere, you would have a key that can decrypt your secret living on the host. So the container would spin up, send the encrypted secret to the secret manager. It would check the policy to say, hey, is this container, which we validated the signature for and the identity of, is this allowed to use this key? If it is, then it'll decrypt the secret and sort of inject it back in the container. And this is kind of flipping this model on its head in that it's becomes not a question of database management, but a question of key management. Now, you can split this up really nicely, so each team has its own key, and each team can manage its own policy, and you can have multiple containers running on the same host, and sort of everybody manages their policy separately. It's also potentially worthwhile to just have a separate server that has access to these keys, and rather than having the secret manager talk locally, it can talk to something remotely. And this is what PAL is. So this is introducing the project, which is PAL, Permissive Active Link, Access Link, which is this is a term of art, I guess, from nuclear weapons. It allows you to connect the arming data to the bomb, and it goes along the theme of some of the other open source projects, and I'll show you those further along the line. But yeah, it connects the bomb with the arming data, and that's essentially what this secret manager tool does. So the basic workflow is this. You encrypt secrets before you master the container. PAL is the entry point for your Docker container. So rather than running the application directly, you run this wrapper around the application that does secret unwrapping first. And so it takes your secret, sends it down through a Unix socket down to PAL-D, which is the component that's sitting on the host. And actually, let's look at this more visually. So PAL is your entry point. And what happens is when your container spins up, PAL will talk down to PAL-D, which will talk to Docker Notary and verify that the container is who it says it is. And then PAL-D has a bunch of plugins or different ways that it can decrypt the secret. And this is really up to what secret management or what key management tool you want to use. So for example, PGP is one option. So PAL-D can talk to PGP, to a keychain, and say, okay, well, decrypt this secret for me and send it back up. So we talked about Vault and Knox and all these things before. PAL-D is not a secret management tool. It's a container identity bootstrapping tool. And this is very important to say because we have a million secret management tools. And every single one of them relies on a secret to get bootstrapped to the point where it can deliver secrets. So secret management, it is really more of a term of going from one secret to many. And what PAL gives you is that very first secret, the identity secret of the of the container itself, or the Docker container that wants to get access to your secret management tools. Now, applications. I'm going to walk you through a few ways. So PAL is something that we've deployed at Cloudflare and we're using for a lot of our internal systems. We have a data processing pipeline that is all built on Docker and Mesos. And the reason that this came about was we had secrets, needed a way to manage them. And we did have a secure way to identify hosts and enroll them, but just not a secure way to inject the secrets into these containers. So let's talk about a few applications. Service-to-service authentication. Now, if you're running a distributed system, it's sort of popular nowadays to call it a microservice architecture, where you'll have multiple little tiny projects, little tiny applications that handle pieces of the puzzle. And whenever you take a large monolithic project and split it into tiny pieces, they need to be able to trust each other to do the right thing. And just being in the same data center is not enough, especially if people can sort of take any application they want and deploy it and spoof other applications. This is well within the threat model. But if you're taking your service and you're splitting it up into tiny services, they need to be able to trust each other. And this is what PAL can do if you have a service-to-service authentication framework. So the way it works is every service gets an account, a service account with an identity key pair, and the private key is encrypted with PAL. And on launch, the container spins up, decrypts this private key, and talks to the service authentication service and gets what's basically a bearer token, a token that allows it to talk to other services and sort of assert claims and say, for example, if you have one container that is your API and one is your database, the API thing can come up and then it will get credentials to talk to the database. And there's a tool that we've started using and other people have experimenting with. It's a standard from the W3C called Jose, and JWT is a JSON Web Token. It's just a simple way to encapsulate a bearer token. You have claims and they're signed. That's basically what it is. So when your service spins up, it can talk to the identity service, the service authentication service, get a bearer token, and then talk with any other service, and those services will know that this is who they said they are. That's one application. This kind of has an enterprise password manager analogy. Rather than a person trying to log into get an access to the Visa account, you have this robot, this sort of automated machine, and he says, okay, here's a jot that says, can I get one that has permissions to the corporate Visa account? Here's my self-signed identity jot, and this guy says, no way, Jose, you're not on the list. That's my Jose joke for the day. Yes. Perfect groaning. I appreciate that. Anyways, okay, so this is one application. Another one that a lot of people have been using is PKI authentication. Rather than using bearer tokens to talk to each other, I mentioned there's passwords, bearer tokens, and private keys. PKI-based private key is a way that applications can authenticate themselves to each other. And if you have a service spin up, you can encrypt this identity credential in PAL, and then it can talk to a CA and get a certificate, and then it's absolutely clear that the service is who it is, who it says it is, and then you can do mutual auth TLS between different services and be able to spin things up. A third application that I had hinted at before was this secret manager integration. So if you're running Vault or one of these other tools, I mentioned they need an identity secret to spin up. So that's what PAL can give you, is you can embed this identity secret into your application, and then it can talk to your secret manager tool and get all your API keys, your passwords, and all these sort of things hooked up, which is nice. Then you don't have to use Tofu to trust every one of your containers. You're moving the trust from the container down to the host. This fourth application is something that is interesting, and this would maybe have helped the Vine case, which is you can encrypt your code with PAL. And when your container launches, then you can decrypt your code. So if you have a Docker registry and someone has access to it, then they don't get anything. All they get is this encrypted code, which makes it a lot more resilient to if you screw up your authentication or someone gets access to it, it kind of protects your intellectual property. Now, with all these applications of PAL, there are a couple sticky parts. One's revocation, which is, if your secret's in your container, you have to roll a new container to build your secret, to build a new secret. That's sort of a downside to this. And building the policy for who can decrypt what in terms of applications is difficult. But luckily, we have another open source project, and this has been open for, I guess, 2.5 years or so, that is really cool, that allows you to do this, and PAL is integrated with it. It's called Red October. So I don't know, has anybody heard of this tool? It was on our blog, a few people. But it's basically an encryption and decryption oracle. This acts as your key decryption service. And it does have cryptographically enforced policies. And by that, I mean you can encrypt a secret such that 2 out of n people need to approve it to allow it to decrypt. And this is enforced cryptographically. So this is oftentimes called the 2-man rule, the 2-person rule. And Red October allows you to do that. You can take a secret and encrypt it such that you have basically 2 people that can decrypt it. And we've recently expanded it to include what are called arbitrary Boolean predicates, which you can just think of just any combination of people need to approve, you can define. So in this case, you can have A could be like a super admin. You need A and one of a group of B, C, D to approve it. So this allows you to have much tighter controls as to, a person manually approving how to decrypt something. It has a UI, and the features are, I guess the workflow is that when you encrypt something, the owners you can encrypt it to a set of owners of the secret, and also you can give it labels. So when you want to decrypt it, the owners need to delegate their passwords to this service or delegate their credentials to this service. And they can do so for a limited number of uses, a limited number of times, and for a limited set of users to decrypt it, as well as a limited set of labels. So if you have a secret that you encrypt, you can say, I want 2 out of all of the managers in the company to have to approve this to decrypt it, and my secret's going to be called Postgres database secret or Postgres database password. And then 2 out of those people can delegate to Red October for 1 decryption within a 5-minute window, and to the PAL-D container, not the container, sorry, the PAL-D host as a user to decrypt it. So they can say, okay, I want this secret to be deployed on this host. I'm going to allow it to happen once, and I'm going to allow it to happen in the next 5 minutes, and I'm only going to allow this person to do it. And it allows you to have some pretty fine-grained controls over how these secrets can be decrypted, but it also allows you to set things up so that they're completely automated, or you can reduce the amount of user interaction. So you can say, if you want, you can delegate for, say, a week. You can say, okay, well, this can happen 100 times in the next week. And any one of the machines in my production infrastructure can decrypt it. And so then if you have Docker machines go up and down, spinning up or spinning down, you can have it happen 100 times within the next week, and you don't need any manual interaction. But you do have the full logging and auditing of every time someone goes to decrypt this. So I had sort of alluded to that in that tangent, but back to secrets is the idea is you provision hosts a per machine username and password with Red October, and then you encrypt your secret with the label belonging to your container and a set of owners, and then before you deploy, 2 out of the n owners, or whatever the Boolean predicate is, decide to delegate their password to Red October, and then the user accounts in the machines who are expected to run this container, and every decryption is logged. And if you look at this in a visual way, it looks a lot like one of the previous models, except in this case, you have owner 1 and owner 2 who delegate password, user, label, time. And at any time this is delegated, you can kind of restrict it to a subset of your infrastructure if you want. You can restrict it to one place or another. And this is the main use case that we have for PAL. Now, I mentioned PAL is a tool. We are planning to open source the tool very soon. And in the meantime, if anybody wants to come up to me after or talk to me on Twitter, I can get you early access to this tool. But before I do so, I'm going to show you a quick demo. It's pretty text heavy, but it will at least show you how PAL-D actually works. So, all right, so I have this nice PAL-D demo. So first step is to start Red October. This is going to be fun for everybody to read, but basically you start up the service and it gives you that web UI that you want, or you can sort of manually connect to it with a command line tool or with curl. But start Red October. Let me show you step one is encrypt the secret. So we have two secrets here. One is defect at dawn. Secret 2 is one ping only. And essentially, you can encrypt it by just curling or sending the secret to Red October and giving it a list of owners. Jack Ryan, Marco Ramius. These are the accounts of the owners that we had created. And it spits out this YAML file down there that says demo, that has an environment variable and a file. And so the way that you write secrets down in Red October is you just have basically a configuration file that says secret, and then you have RO, and then a bunch of ciphertext. And if you have a file, you have a file name, colon, RO, colon, a bunch of ciphertext. So, all right, this is our secret as encrypted. It does get inflated quite a bit because you're encrypting to multiple people. So PAL-D is, as I mentioned, it's something that runs on the host, and it gets a Unix socket and a small configuration, and basically it just sits there waiting for Docker containers to try to connect to it. Let's see. So PAL-D's running and listening, which is good. Delegate authorization. This is where Marco Ramius and Jack Ryan give their passwords to Red October for 1 hour, 10 uses. And you can sort of see right here. And the label of the account of the demo machine and the label of demo. So delegate authorization. All right. So it's talked to Red October, and that's good. Run PAL. So as I mentioned, PAL is your entry point to a Docker container. And if you don't know how Docker containers work, essentially they just run one command. And then that command is usually your application. In this case, PAL is your command, and it wraps another command. So if you look right on the line right there, it says root bin PAL dash socket. It says the socket that it's trying to connect to. And root bin demo is our demo application. And this demo application is really just either reads a secret from file or secret from disk, and it contains this encrypted YAML of the secret and prints it out. So let me run this. So run PAL. All right. So it says it has connected to PAL-D, sent it the secrets, and PAL-D has sent it to Red October to get it decrypted, and then embedded it into the Docker container itself. And then the last step is query demo, where we just curl this Docker container, the secrets endpoint that is basically just going to print out your secrets. You don't want to build a service that just prints out your secrets. That's sort of the opposite of what you want to do here. But for a demo, it's quite nice. So environment secret, defected dawn, file secret, one ping only. And if you see here, this is the secret file and the secret environment. And voila, that's PAL in action. Thank you. All right, so we've got a little bit of time left to talk about, to answer questions, but we're basically at the end. So in conclusion, PAL, this is a tool for bootstrapping your container's identity. It allows you to securely have secrets, and if you're building a production infrastructure, don't leave your secrets sitting around in source control. Don't leave your secrets, your passwords, anything in a place that it's not unencrypted and if it is encrypted, don't just leave that key lying around anywhere either. What Red October gives you is this nice abstraction where you don't have any keys sitting around, you have a decryption service, and that decryption service can be time limited, which is really nice. So PAL is complementary to Vault and all these other these sort of secret management tools. It helps bootstrap the identity that makes that secret management world possible. So where to get it? PALD, just as a shout out, Joshua Kroll was the main developer for this, and a bunch of other people at Cloudflare contributed as well as myself, and it will be soon on GitHub with a very permissive license. Right now it's Linux only, and it does have built-in Mesos Marathon integration, because that's our orchestration framework that we use. And if you want early access, you can email me, nick@cloudflare.com. That's it. Thank you very much.
Questions?
When you're speaking about the interaction between the container and PAL-D, and the PAL-D is supposed to bootstrap the identity of the container.
Yes.
But the connection that you have over the socket leaves, I think, the question of who, in fact, executes the call somewhat open. Right. So how do you identify the actual caller on the other side of that call?
Right. So when the connection from the container to the host happens over the socket, you can actually inspect the UID of the program that's making that connection. So having that UID as an inspection point allows you to measure it, and then you can use Docker Notary to validate that container. Well, then you match to see whether that is the right UID that's been sent there. This is the Mesos Marathon orchestration part. You compare it with, this is all the innards of PAL-D, but you compare the UID with what it's supposed to be, and then you validate the signature on the container on top of that. So there's more details we can talk about it after.
Sorry, so everything I know about Docker I just learned right now. So I'm curious, as running services on a host, is it possible to still use this, like Red October, to manage secrets?
Yeah, absolutely. Red October itself came well ahead of using PAL. And the main use case for it was sort of long-lived, sensitive secrets. Maybe not ones that are deployed on servers, but ones that are used inside of build systems or for code signing or for things like this. So if you wanted to use Red October to manage your secrets in a sort of traditional host environment, go nuts. It's great for that use case.
So I'm curious, I guess, why did you write a new tool versus using something like Consul Vault or I guess Chef Vault or whatnot?
Yeah, I think the main point I was trying to emphasize in this talk is that these tools work, but they need an initial identity credential to work. And so how do you deploy that? And you can do that very well on a system where you have a bunch of hosts and you have configured them manually, and you can deploy secrets to those hosts. But when it comes to secrets coming directly from the Docker container itself, there's no way to bootstrap Vault. I mean, this is the way that we found to bootstrap Vault. There was nothing else out there that would do it for us. So that's why we built this new tool.
If I'm the chief technology officer or I'm a security auditor, how easy is it to look at a system that's been set up this way and understand what the policies are and exactly what's going on?
That's a good question. Yeah, as occurred to me when I was just explaining all the different points of configurability for Red October, it is quite complex. But if you do have an environment where you can use just a simple subset of these, it's simple to write down the policy. But yeah, I guess this, along with a bunch of all these other new tools, are new, and explaining them to an auditor is potentially difficult. But I would say that explaining how you manage secrets without something like this is potentially more troublesome.
You mentioned earlier about the trade-off between storing secrets locally that are encrypted and passing them to a central secret authority or key management solution versus just storing the secrets and having them manage all of those there. And then I feel like that wasn't addressed when we talked about specifically PAL. What are you guys recommending users do in that situation?
Right. So at first, when we built PAL, we sort of thought we could just stuff a bunch of different secrets in here, and you could just put all your secrets that you want for your container inside of PAL, and when it starts up, they'll all get decrypted. But as we went further along, it made a lot more sense to just make the amount of things that you do with PAL as small as possible. Just limit it to the identity of the container, and that's it. And I think having a large secret management system is valuable, and that's why you still want to use Vault or Knox or something like, or KeyWiz with something like this, but restrict PAL to just the identity of the container itself.
Okay, we need to stop there to move on to the next talk. So once again, thank you, Nick.
All right, thanks.